Hello everyone, welcome to our presentation on teamwork challenges in project-based learning, specifically in a research method course for computing students. I'm Murtaza Moulag, and with my colleagues at the Norwegian University of Science and Technology, we have conducted a study examining common challenges students encounter when engaging in team-based research projects. We did this study with the support of the Center for Excellent IT Education, called Excited. Okay, let's dive and explore these challenges and our findings. In this presentation, we'll cover why empirical research methods are essential for computing students, the specific activities included in the research method course, and why project-based learning, or PBL, is a beneficial teaching approach. Then we'll outline our research question, case description, data collection, and analysis, findings, and an updated framework for implementing PBL in research method course. Empirical research skills are vital for computing students, specifically in understanding the broader implication of technology. Computing students need to learn that digital technologies may not be the remedy of all things. Instead, they must appreciate the broader social, economic, environmental, and ethical implications of digital technologies that they design. In this course, they will learn thinking critically about a problem, read research papers and formulate a research question, generate and analyze empirical data to answer the research questions, present a logical and coherent argument, reflect on the process and outcome, and these are the things that they will learn. But the research method course engages students in core research activities, from formulating questions and analyzing data to presenting coherent arguments. The focus is on critical thinking, enabling students to frame questions and reflect on their findings. These activities aim to bridge theoretical learning with practical research, preparing students for future academic and professional challenges. Our research is grounded in the Holz and colleagues framework, which provides a structured approach to teaching research methods. It outlines 4 main quadrants: defining goals, gathering data, analyzing it, and then concluding. This framework is foundational in shaping our approach, though we've identified areas for improvement, particularly in teamwork. Project-based learning, or PBL, enhances traditional teaching by engaging students with real-world challenges. Students are motivated by active learning, where they develop critical thinking through hands-on problem solving. PBL has shown positive outcomes in terms of student satisfaction and deeper understanding of material, so making it ideal for a research method course. In a comparative study, students also favored PBL over traditional lecture-based teaching because they could develop critical thinking by solving problems, deepening their understanding of course material. Working on research projects may also help students develop critical thinking skills and find a way to incorporate these skills into their professional training. So, the research question in our study is that what teamwork challenges do computing students face in a project-based learning course in research methods? So if we use this PBL in a research method course, what are the challenges by the students? Through this, we seek to understand how team dynamics influence learning outcomes, especially when students are expected to work collaboratively on complex research tasks. So we conducted a case study in a research method course for master students in computer science. Students were organized into teams and tasked with completing a research project from start to finish, including drafting proposals, conducting research, peer reviews, and final presentation. This real-world setup allowed us to observe and analyze teamwork dynamics. In this course, in our case, 100 participants every semester participates in this course. They are from different fields of study, for example, information systems, software engineering, and computer science. They are grouped into teams of 4 to 5 team members in each group, and then work on a project for 17 weeks to produce 2 outputs, a research proposal and a research paper. They are doing different activities in this research method course, from topic selection to literature review, research design, data collection, data analysis, and also paper writing. They also do some sort of planning and collaboration through the project. Our data collection involved 2 primary methods: reflection reports and interviews. We did some kind of semi-structured interview with some students. And also, each student submitted a report reflecting on their project experience. We also did a data analysis by using qualitative techniques like open coding and peer debriefing. Our study uncovered several recurring teamwork challenges in project-based learning within a research method course. These issues primarily stemmed from differences in commitment, motivation, and approach among team members. Each challenge not only affected the project outcomes, but also highlighted areas for improvement in structuring and supporting team-based learning environments. We'll explore these findings across 4 main stages: topic selection, literature review, research design, data collection, data analysis, and writing. So let's look at the findings of this research. One of the first challenges faced by teams was during topic selection. We observed that many teams struggled to reach consensus, as members often had different preferences. Some students tended to gravitate towards popular and cutting-edge technologies like AI or blockchain, without grounding these choices in practical research questions. Additionally, in some cases, stronger personalities dominated the selection process, limiting equal contribution from all team members. These early disagreements could delay progress and set the stage for further conflicts down the line. For example, one of the students told us, apart from this, the group seemed to take an interest in the intersection between AI and medicine, without having any specific reason to choose this topic. The literature review phase was also posed unique challenges. So teams often relied on only a few members to conduct in-depth reviews, resulting in incomplete background research. Some team members were more inclined to rush through this step to move on to data collection, leading to a weak foundation for their research. Additionally, many students lacked experience in searching for and evaluating sources effectively, which affected the quality of their literature reviews. These issues sometimes resulted in poorly scoped projects or in insufficient understanding of the research topic. For example, one of the students told us, we sort of agreed, okay, we have this topic, everybody at least read 5 research articles and summarize, and we'll speak about it. Not everybody did that, unfortunately. Designing the research strategy brought out a different set of challenges. For some teams, members with a stronger interest in software development preferred hands-on programming over rigorous empirical research. These preferences sometimes diverted the project from answering research questions to focusing on technical implementations. Furthermore, due to time constraints, some teams chose quicker, more convenient research methods, like surveys, over more robust but time-intensive methods. This selection impacted the depth and quality of their research findings. For example, one of the students told us these choices were largely motivated by my personal desire to incorporate some practical programming and performance testing in the project, rather than deriving from the needs of our research topic. Data collection also presented some hurdles for the teams. Teams often adapted their research question to align with data that was easier to collect, sometimes at the expense of research validity. For instance, opting for simple surveys rather than in-depth interviews ended in non-participation of some team members. This non-participation resulted in some kind of activities in the teams. This limited the analytical insight that comes from hands-on data engagement, and in some cases reduced motivation across the team. Also, coordination for data collection was difficult due to different schedules, within further impacted the teamwork. One of the students told us if the people working on the report could use their time on observation or other data generation methods, I think the motivation would increase as they got to do some practical work, not only writing. During data analysis, we observed that teams often struggled with critical discussions. Members tended to avoid debating or challenging each other's ideas, which could have enhanced the analysis. Moreover, many teams lacked a shared understanding of the conceptual framework, which led to fragmented analysis efforts. Without a unified approach, teams face difficulties integrating their findings into a coherent narrative, resulting in weaker research conclusions and insights. For example, one of the students told us, I feel like if you had like a really good research question or something you would propose and proposed it, most people would probably jump over to it and be happy. The writing phase also highlighted issues in collaboration. Many teams adopted an individual incremental approach, where each person focused on a separate section of the paper. However, this approach often led to inconsistencies and misalignment in the final report, as sections weren't well integrated. Sometimes teams also took shortcuts to save time, such as using team members as study participants, which compromised the research internal validity. These issues underscore the importance of a more collective, iterative writing process in team projects. For example, one of the students told us, I think it was a mistake to change from a collaborative, iterative approach to an individual incremental one, as it negatively affected our productivity. The ones responsible for the later sections experienced a lot of downtime in the early phases due to sections depending on previous sections. Lastly, we noted several overarching teamwork challenges. Planning and collaboration were often overlooked, which impacted all project stages. Team members sometimes fail to manage risk, like absenteeism or uneven contributions, leaving some members burdened with extra work. Motivation was also a recurring issue. Some students lacked engagement due to low perceived relevance of the course to their computing careers. Addressing these broad teamwork dynamics could enhance the overall success and the learning outcomes of PBL in research method course. For example, one of the students told us the project phase started good, but the team was less motivated over time, and people started missing meetings. This was specifically frustrating, and one of our reasons might be because they had little connection to the team and the individuals. In light of these findings, we propose an update to the existing framework for teaching research methods with project-based learning. The Holz and colleagues framework, which guided research activities through 4 quadrants from defining goals to data collection and analysis, served as a foundation for our study. However, our findings highlighted a critical missing element: effective teamwork strategies. To address this, we suggest adding an overarching layer titled How to Do a Research Project in a Team. This new layer emphasizes key aspects like planning, collaboration, risk management, and communication within team. Each stage of the research process benefits from this team-oriented focus. For example, when selecting a topic, teams can integrate all members' interests, helping to prevent conflicts. Also, during literature review and data collection, teams can leverage individual strength and ensure balanced contribution. This framework encourages a collective approach to planning and executing research projects. By this extension, we aim to foster a new culture of collaboration in the students' teams. And by adding this layer, we aim to address the unique teamwork challenges in PBL and support computing students in building essential research and interpersonal skills. This updated framework can also guide educators in designing more effective and collaborative research courses for computing students. Our finding also suggests direction for future research. We recommend exploring strategies to address identified teamwork challenges, refining research skills specific to computing students, and balancing computational with critical thinking skills. These steps will strengthen research method courses and better prepare students for real-world challenges. Thank you for your attention. Through this study, we hope to improve the design of PBL-driven research courses, making them more impactful for computing students. If you have any question or would like to discuss this further with us, we'll be glad to hear from you in the comments. Thank you.